Hi, good day all. Myself Srividya. I am currently undergoing internship with Spark Foundation on data science and business analytics. Today I am going to take you through on task number 6, that is prediction using supervised machine learning model. Here we are going to implement decision tree algorithm for this. Starting with the problem statement, create decision tree classifier for iris flower dataset. Species category of this flower should be identified in prediction. Here we will find different classes of flower based on length, width of sepals and petals. It is multi-class problem since it has three classes: Iris setosa, Iris virginica and Iris versicolor. Outcome expected is if we feed any data to this classifier, it should be able to predict the right class and identify the flower and also visualize the decision tree classifier graphically. I have used Python in Jupyter Notebook to perform this analysis. Let's start our multi-class classification problem. The first step is to scrutinize the data on hand prior to start the EDA. Dataset has around 150 rows and 6 columns explaining the characteristics of a flower. Target column is species and it is having categorical nominal data type. Hence it is a classification problem. The next step is to check the column data type and ensures no null values present. Post completion of the same, we start the EDA. Table and heat map reconfirms no null values present. Analysis shows that different classes of iris flower species are equally distributed and it has no class imbalance. Upcoming charts shows the visualization models of different characteristics of flowers. The flower sepal length and sepal width is directly proportional to the petal width and petal length and vice versa. Next graph shows that sepal length and width of Iris virginica flower, which is green in color, is higher than other two species. This graph indicates that petal length and width of Iris virginica flower is higher than other two species. This box plot again proves that Iris virginica flower sepal and petal measurements are higher than other two species. Next comes the data pre-processing and feature engineering outcome of the dataset. Most positively correlated with target is petal width and most negatively correlated column with the target is sepal width. Also, the data distribution shows not much skewness present. Next is the visualization of correlation, as we said above. Sepal width column has outliers and it shows not much skewness present. We used quantile method to remove the outliers. Now, outliers of sepal with column got remove. Skewness removal of the dataset is done here. It is followed by scaling to get better model performance. This is distribution of data after removing skewness. It shows not much skewness present here. We used decision tree classifier for our model prediction. It is one of the best predictive models because it allows partition of data in a very deep level. It considers all possible outcomes of decision and traces each path to a conclusion. It enables comprehensive analysis of consequences of every possible decision that needs further analysis. And it will also reduce ambiguity in the decision-making process. Hyperparameter tuning done here using the grid search CV. We selected the best parameters using the grid search CV. It is to improve our model performance. It selected here Guinea because it works like gaining information from splitting the dataset using one of the features in our dataset because petal length gave more information than others. See its Guinea, it's 0.664. When Guinea becomes 0, that's the end. No other further splitting will take place. So, petal length is the parent node or the root node. Here, max feature is maximum number of features we use to make predictions. Maximum depth is how much deep the tree should go. In our tree, it went up to 4 steps. Minimum split is 2 because our tree makes 2 splits and minimum sample leaf should be 1. We used these selected parameters to tune our models for better prediction, and it gives accuracy score of 90%. Cross validation is done here and its score is 95%. Confusion matrix and AUC ROC curve are plotted here. It indicates that iris setosa coverage under the curve is higher than others and has better prediction among others. Conclusion clearly shows that efficiency of using decision tree classifier as it can test the data with more accuracy. We save the model and our model score is 90%. Now you can feed any new data, that is test data, to this classifier and it would be able to predict the right class accordingly. See the See the tree. The maximum depth is 4, split is 2 and minimum leaf is 1. Apply same procedure as we did to the dataset earlier, like outlier handling, skewness removal, and then do scaling. It is the prediction of unseen test data, and the accuracy of the new test data shows around 88%. Flower species are identified and classified mostly by petal, sepal width and length features. This concludes the task on prediction using decision tree classifier. Thanks for the opportunity.